In this video, we're going to look at Newton's first law. We're going to find out what Newton's first law is, and we're going to apply it to various situations to find how objects will move, depending on whether there is a resultant force acting on them or not. Please start by pausing the video and doing these questions. You should have now done these questions. Please pause the video while you mark your work and press play once you're ready. So just to remind you of a few things, in question 1, the reason why the resultant force is 320 newtons upwards is that there are equal forces to the right and to the left. So horizontally, you have 340 minus 340, which gives you 0 newtons. But vertically, you have 550 newtons up and 230 newtons down, which gives you 320 newtons upwards. You must include direction if you're being asked for a force. Why do you need to include direction? Say your answer to the video. You should have said because force is a vector quantity. The next few questions are all definitions and units. Remember, acceleration doesn't just mean speeding up, it means any change of velocity at all. What type of quantity is velocity? Say your answer to the video. Velocity is a vector quantity, which means it also has what? It has magnitude and direction. So therefore, a change of direction is also considered an acceleration. So instead of me explaining to you what Newton's first law is, I want to get your preconceptions first. I want to get your ideas. So if I were to tell you that there are forces acting on this object here, I would like you to draw a force diagram where you draw the object as a dot and then you draw some arrows coming out of that object to show what forces must be acting on this car for it to be not moving. I'd like all your forces to be horizontal. So for example, you could draw equal forces to the right and to the left, or you could draw a bigger force to the right and a smaller force to the left. Or of course, you could draw a bigger force to the left and a smaller force to the right. So I'd like you to choose one of those options, and I'd like you to pause the video while you draw your diagram. You should have now drawn a force diagram for not moving. Now, often people struggle with this because they think if something's not moving, then there won't be any forces acting at all. Well, it's true that there might not be any forces acting at all. There might be just no forces acting at all, but there might be forces. And if there are forces acting on it and it's not moving, those forces must be equal and opposite. So they must be in opposite directions and equal. So if I have two forces which are equal in magnitude, so I could make up some numbers. So I could put 100 newtons to the right and 100 newtons to the left. This would be not moving because the resultant force is, say your answer to the video, the resultant force is 0 newtons. So it's therefore not moving. Let's do another example. Here's a car moving at constant speed to the left. I'd like you to draw a force diagram for what you think the forces acting on this car are. Pause the video while you do that. You should have now drawn a force diagram for this car. Now, what most people do is they think if it's moving to the left, there must be a bigger force to the left and a smaller force to the right. But that is not true. So if you did that, thank you for doing that. That's a really common mistake. If something's moving at a constant speed to the left, the forces are actually equal again. So I'm going to do two equal size arrows. So this force might be 300 newtons, and this force might also be 300 newtons. So this usually surprises people. If an object is moving at a constant speed in a constant direction, the resultant force is actually, say your answer to the video, you should have said that the resultant force is actually 0 newtons. So things move at a constant speed if the resultant force on them is 0, and this usually surprises people. Now, that should help you do this one. So pause the video while you do this one. You should have now drawn a force diagram for this situation. A common mistake people make is they think if something's moving at a constant speed to the right, there must be a bigger force to the right and a smaller force to the left, but that's not true. If something is moving at a constant speed to the right, the forces are actually equal in either direction. So perhaps this force might be 7 newtons, and this force might also be 7 newtons. Therefore, the resultant force is what? So your answer to the video. The resultant force here would be 0 newtons. So that's a really surprising result. People get surprised by this. When something's moving at a constant speed in a constant direction, the resultant force is actually 0. There are equal forces in both directions. Have a go at this one now. Pause the video while you do that. So you should have now done this. For an object accelerating to the left, there will always be a bigger force to the left and a smaller force to the right. There could also be no force to the right. So actually, I'm going to leave it as if there's no force to the right at all here. So in this situation, this object would be accelerating to the left because there is a resultant force to the left. A resultant force to the left. So a resultant force to the left means that the object is accelerating to the left. Remember, we discussed how people make that mistake that they think if something has a resultant force to the left, it's going to move at a constant speed to the left. No, we've seen constant speed. What will the resultant force be? For a constant speed, the resultant force will be 0 newtons. So when there is a resultant force to the left, we actually get acceleration to the left. Pause the video to do this one now. You should have now done this one, and hopefully you've realized that you need a bigger force to the right and a smaller force to the left. Doesn't matter what those forces are, as long as it's a bigger force to the right and a smaller force to the left. So overall, you have a resultant force in which direction? Say your answer to the video. Overall, we have a resultant force to the right, and that causes an acceleration to the right. So we're now going to formalize this by writing down what Newton's first law is. So Newton's first law, in words, says the following. An object will continue at rest, which means it's not moving or stationary, or at constant velocity which would be an E, unless a resultant force acts on the object. Pause the video to copy down this statement and press play once you're ready. So this is Newton's first law. So what I want to do is look at the effect of Newton's first law. So we're going to start with considering when there is no resultant force on an object. So there's two options for there to be no resultant force on an object. There could be no forces at all. That would be 0 resultant force. There could also be balanced forces, meaning the same force in two directions. So we could have 50 newtons to the right. What would be the force which would balance that exactly? Say your answer to the video. You should have said a force of 50 newtons to the left. That would also be 0 resultant force. You could also have lots and lots of forces. You could have a force to the right, you could have a force to the left, you could have a force up, you could have a force down. Let's call these forces 1, 2, 3, and 4. In what case would there be 0 resultant force on this diagram? Pause the video while you write down your answer and then press play once you're ready. So you should have said that in this diagram, there'll be 0 resultant force when force 1 equals force 3 and when force 2 equals force 4. So the idea is that we want our vertical forces to be equal and we want our horizontal forces to be equal. And as long as our vertical forces are balanced and as long as our horizontal forces are balanced, there is 0 resultant force on that object. Now, whenever there is 0 resultant force acting on an object, whether it's no forces at all or balanced forces, what have we said the motion will be? Say your answer to the video. We've said it will either not be moving, so it's either stationary, so with an A, ooh, sorry about that, the A too early, stationary, or moving at constant velocity. Moving at constant velocity doesn't just mean moving at constant speed. What else does it mean? Say your answer to the video. You should have said in a constant direction. So you can either say moving at constant speed in a constant direction, or you could just replace this whole thing with the word velocity. So moving at a constant velocity. So when there's zero resultant force acting on an object, the object is either not moving or it's moving at constant velocity. Now let's consider when there is a resultant force acting on an object. So a resultant force acting on an object is whenever there is not zero resultant force. So there's a large number of different ways to get a resultant force on an object, but we'll look at a simple example. So for example, let's say you have an object where there is a 1000 Newton force to the right and a 200 Newton force to the left. What is the resultant force acting on that object? Say your answer to the video now. You should have said that there is a resultant force of not just 800 newtons, but you should have said it's 800 newtons. Finish my sentence. You should have said to the right, because force is a vector quantity. So 800 newtons to the right. So what that means is this object will be accelerating to the right. What we say is there is a resultant force to the right. So therefore, I'm going to use this symbol for therefore, there is an acceleration to the right. Now, please never say the acceleration is 800 newtons to the right. The acceleration is not 800 newtons to the right. The resultant force is 800 newtons to the right. The acceleration is going to be a different number, but the acceleration is to the right. But be careful. That does not necessarily mean it's speeding up to the right. There are two choices. It could be moving right and speeding up. So if something's moving to the right and there is a resultant force to the right, then it will be speeding up. But it could also be moving left. Now, if it was moving left and there is a resultant force to the right, what do you think its motion will be doing? Say your answer to the video. Well, if it's moving left and the resultant force is to the right, it will be slowing down. This is a really crucial point that people get confused about. They think, oh, there's a resultant force to the right, so the thing must be moving to the right. That's just not true. If the resultant force on an object is to the right, it does not mean it's moving to the right. It could be moving to the right and speeding up, but it could also be moving to the left and speeding down and slowing down. All of this applies the other way as well. I could have a resultant force to the left. And if I had a resultant force to the left, that would cause an acceleration to the left. And either something could be moving left and speeding up or moving right and slowing down. I'd recommend if you found that counterintuitive that you rewind the video and watch it again. We're now going to define something called inertia. So Newton's first law is also known as the law of inertia. So Newton's first law can also be known as the law of inertia. And inertia just means the following. It's the tendency, so that means what it wants to do. So the tendency of an object, so that means that the kind of natural inclination of an object, what an object naturally will do, the tendency of an object to continue at a constant velocity. So this is the idea that objects will continue at a constant velocity unless a resultant force acts. So if there's no resultant force acting on an object, what will the object do? Hopefully you've said that the object will just continue in a straight line at a constant speed forever, a constant velocity forever. So objects do that. The only time they don't is when there's a resultant force. Now, most objects you've ever seen will have a resultant force acting on them, which is why they don't just carry on in a straight line forever. And we'll look at a couple of real examples soon. So what I'd like you to do now is redraw those diagrams from the beginning of this video. So I'd like you to draw 4 objects. On your first object, I would like you to draw the forces if it's stationary. On your second, I'd like you to draw the forces if it's at constant speed. On the third, I'd like you to draw the forces if it's accelerating to the left. And on the fourth, I'd like you to sketch the forces if it's accelerating to the right. Pause the video while you do that. You should have now done these examples. For question A, you should either have no forces or you should have two equal and opposite forces. They could be labeled with numbers or they could just be arrows the same size. For B, it's the same as A. So either there's no forces at all or there's equal forces in opposite directions. So both of these are acceptable for A and for B. So you could have no forces at all or equal and opposite forces. Accelerating to the left means a bigger force to the left and a smaller force to the right. You could also have no force to the right at all. And if it's accelerating to the right, you need a bigger force to the right and a smaller force to the left. You could also have no force to the left at all. Please pause the video while you mark your work and press play when you're ready to move on. Okay, we're now going to look at a couple of real examples. So the first is a tennis ball. So if I do a very bad diagram of a tennis racket and a ball, so while the ball is in contact with the tennis racket is applying a force on the ball. But later, when the ball has now left the tennis racket, so the ball might be moving in this direction, but there is no longer, so this was earlier, and this is later. So this is my earlier diagram, and this is later on. So there is no longer any forward force acting on the ball. So I'm going to draw that force. That force is not there anymore because the ball is no longer in contact with the tennis racket. So actually at this point, the only forces acting on the tennis ball are weight downwards and drag forces in the opposite direction to its motion. So that would be air resistance. So those are the only forces acting on the ball now. So I've drawn this arrow up here. This just shows you the velocity. That's just the velocity of the ball. So the ball is moving to the right, but there is no force to the right. Look at the diagram. There's no force to the right at all. There's just a force downwards, which is the ball's weight, and there is air resistance backwards. Yet the ball carries on moving in the forwards direction. So if you think about this, what must the ball be doing? So there's two things I'd like you to answer. What do you think the ball is doing horizontally? And what do you think the ball is doing vertically? So pause the video while you write down what you think. Press play once you're ready. So horizontally, the ball is moving in which direction? Say your answer to the video. The ball is moving to the right. What direction is the resultant force horizontally? Say your answer to the video. The resultant force is to the left. So it's moving to the right, but the resultant force is to the left. So therefore, it must be slowing down. What about vertically? So have a look at the diagram. What's the resultant force acting on the diagram vertically? You should have said there's a resultant force downwards. So therefore, what will the ball be doing? It's going to be speeding up towards the ground. So speeding up towards the ground. So it's going to be accelerating in the original definition of acceleration before you learnt about acceleration meaning any change of velocity. So that's a real life example. So when you're hitting the ball, there is a force acting on the ball, but once the ball has left the tennis racket, there is no resultant force in the forward direction acting on the tennis ball anymore, but the tennis ball still carries on moving forwards, even though the resultant force is in the opposite direction. And that's really, really interesting because people's natural thought before they study this topic is they think if something's moving in a direction, there must be a force in that direction. But here's a very straightforward example to show the ball is moving to the right, but there is actually no force to the right at all. Of course, though, the ball does slow down because of air resistance and eventually does hit the ground because of gravity. So there are resultant forces. There is a resultant force acting on the ball, which is why it slows down and it hits the ground. But what about if we remove all external forces? Let's go to space. Let's imagine in space, I hit a ball with a tennis racket. So here's my tennis racket and here's my ball. So while I'm hitting the ball, there is a force on the ball. So the ball accelerates to the right. But later, so the ball has now left the tennis racket. So the ball is now here. If that ball is moving to the right, because it's in space and it's in deep space and it's nowhere near any planets or stars, so it's not going to feel the gravitational effect of those planets or those stars, and there's no air in space, so there's no air resistance, there's no drag forces at all, this ball will continue moving in a straight line forever. It only gets hit by the tennis racket once, and whatever speed it gets up to, it will stay at that speed forever in a straight line, without changing speed, without changing direction. Why? Say your answer to the video. You should have said because there is no resultant force. Once the ball has left the racket, there is no resultant force acting on the ball anymore. Therefore, there is no what? What do resultant forces cause? Say your answer to the video. Hopefully you've said acceleration. People might not. People might have said movement. It's not movement. Resultant forces cause acceleration. Things can move without a resultant force. So resultant forces cause acceleration. So what do resultant forces cause? Acceleration. What causes acceleration? Resultant force. What do resultant forces cause? Acceleration. So if there's no resultant force, there is also no what? There is also no acceleration. And that's why this ball will continue in a straight line forever. That's Newton's first law. So you're now going to do a series of questions. I'd like you to pause the video to do these 4 questions. You should have now done these 4 questions. Please mark your work using these answers. You should have now marked these 4 questions. Please now do this series of questions here. Pause the video while you do that. You should have now done this whole series of questions. Please mark your work. Pause the video while you mark it. You should have now marked that question. Please do these questions now. Pause the video while you do that. You should have now done these questions. Please mark and correct them using these answers. You should have now marked these questions. Please do these questions now. Pause the video while you do that. You should have now done these questions. Please mark your answers and correct them using these solutions. Pause the video while you do that and press play once you're ready. You should have now done those questions and marked them. Please now do this question. Pause the video while you do that. You should have now done this question. Please mark this question using these answers. You should have now marked your answers. Please do this last question here. Pause the video while you do that. You should have now done this question. Please mark it using this answer. Pause the video while you do that. Press play once you're ready. So we've learned about, well, you should have now marked that question. So we've learned about Newton's first law in this video. The main things to remember are the definition of Newton's first law. What's the definition of Newton's first law? Say your answer to the video. You should have said something along the lines of an object will continue at a constant velocity unless a resultant force acts, or an object continues at a constant velocity or doesn't move unless a resultant force acts. The other main thing to remember is what resultant forces cause. What do resultant forces cause? Acceleration. Resultant forces do not cause motion. Things can move without a resultant force. Resultant forces cause acceleration. And what does acceleration mean? You should have said something like rate of change of velocity. So what changes can happen when something accelerates? Say your answer to the video. So when things accelerate, they can speed up, slow down, or change direction. I hope this video was useful. Please like and subscribe for more videos on GCSE physics.